So on this first one, you can tell that it is skewed to the right because the mean is greater than the median. And you know, we learned our little thing, if the mean is greater than the median, then you know it's going to be pointing to the right. Okay, on number 2, the middle 50%. Well, that's going to be between Q1 and Q3. It gives you the value of Q1 in the data set, but it doesn't give you the value of Q3. So the way you find this Q3, because you know that the IQR is 600. So just add 600 to that Q1. All right, so on part C, you are giving each employee a $50 raise. So each value increases 50. So all these ones that are a positional value, just add 50 to them. The exception is the measures of spread are not affected by adding 50. So the range has no change, the standard deviation has no change, and the IQR has no change. Okay, so these ones have no change. All right, on part D, you're raising it 10%, so you're essentially multiplying everything by 1.1 to be the original plus 10%. So everything is affected by multiplication. So I just took every number and multiplied it by 1.1. Okay, now here we've got January information and July information. Obviously, very different sets of temperatures. And so we want to see in which one of those months is 55 more unusual. And so that's the one that's going to be more standard deviations away from the mean. So 55, in both of these cases, 55 is the X value for that particular month. So I did X minus the mean over the standard deviation, X minus the mean over the standard deviation. So for January, I get positive 1.9. For July, I get negative 2.375. What is it meaning if it's a positive z-score? It's above the mean. What does it mean if it's a negative 2.375? Below. And what is z-score a measure of? Good. The number of standard deviations away from the mean. So in this case, the one that's more unusual is the negative 2.375 because that's more standard deviations away from the mean. Okay. 3 is also similar to that. You get the z-score for a 1,000-pound steer, and then you get the z-score for the 1250. And the one that was 1,000 pounds had a larger z-score, had a z-score that was farther away from the mean, negative 1.8 as opposed to 1.16 repeating. So that was more unusual. All right, questions on that? Okay. So here, we wanted to just see how they compared to 1,000, how much above or below. So we just subtracted. A straight subtraction of 1,000 only affected the mean. It does not affect the spread. And B is a really good indication of, or a good example of where transformation comes into play. It's transforming, B is transforming from pound values into monetary values. Okay, so that's a good understanding of the change from units. And so you're multiplying each pound by 40 cents. So the mean in the money is 460.8, and the standard deviation of money is $33.60. All right. Now, we drew this. Make sure that you label here the name of it. It's the miles per gallon. Okay. And then I think I put on there to do the context. Well, this is your context values. This is the context values are your X. And of course, I think I put z-scores to put on there also. Those are just your 0, 1, 2, and 3. -1, -2, -3. So those are your standardized z-scores. All right? So when you do those miles per gallon, here are your answers for B through E. B is between 18.6 and 31 miles per gallon. C is 16%. D is 13.5%. And E is 12.4 miles per gallon or less, because you're up here at the lowest 2.5%, so you're in this section all the way out to lower infinity. Yes? Yes, or lower is fine. Yes, that's fine. All right, same thing here. We had the shoe sizes, the average shoe sizes. So we had the context values, which were the shoe sizes. And then I think I asked you to put in the z-scores. So that was your 0, 1, 2, 3, -1, -2, -3. Then you have your percentages. And so here, A is 84%, B is 97.5%, C is 2.5%, D is 97.5%, E is 13.5%, F is 47.5%, and G is 81.5%. And again, all of those came from these percentages that we had filled in last week. You know, like we said, each one of these sections was 34, and then these was 13.5, this was 13.5, and then this was 2.35 and 0.15. All right, and we had talked about that on our notes last time. Okay. All right, so that's the end of that homework. Is there any final questions on that? Okay, so yes. And so all of these questions pertained to the whole number standard deviations, landing right on the 1 standard deviation up or 2 standard deviations up, and so on. But today we're going to learn how to find those percents when it does not land on a whole number.